Alrighty. Hello, everybody. Joining from wherever you're joining from. This is the monthly call for the CentOS Automotive SIG. Let's see, we've got a half an hour today, and not a whole lot to go over, but we do have a few important things. Um, we I would let's see, start with just introduction. For those who are new, if there's anybody new on the call, we do this call about once a month. It is very conversational and not very well organized. So please feel free to dive in with any questions that you might have. The slide deck looks long, but it actually only has the two slides really, the agenda and the technical status that we'll go over in just a second. And then the rest of these slides are just backup, and I usually post the slide deck afterwards. Although it looks like I need to change the logo. CentOS has a new logo this year, so we will just take care of that. So anyway, let's just dive into the technical update. Pierre, do you want to take some of this, or should I just talk through it?
I can talk to some of them.
Okay.
Or do we have Leo on the call to speak about the Sophie and SEV work, because he was the one leading that? I'm not seeing him.
I can cover that, but I don't see him online.
As you may have noticed a little while ago, there was a blog post published on Reddit.com about running containers in cars, and one of the aspects there that we were looking for is to have a system that allows to deterministically manage services across multiple systems, or multiple physical systems, in a way that is compatible with running containers. And to this end, we came up with a design that we like, which is based on systemd. And so Jeffro put the link to the blog post on the chat there. And so we came up with a design on that we like with, that relies on systemd starting the services being containerized application or not containerized application. And then we have on the top of that something called IRTE. IRTE means shepherd in German, and it's a client server relation, basically, where we have a primary node that is being instructed to start services on remote nodes, and then it connects to the agent connects to the local systemd, and the local systemd start and stop the services, and all the communication is going through dbus. And then, so if you have our idea is that there is on the top of it, there is a larger application that would know the ideal state of the systems, and that would just basically tell you to, I need you to start service A on node 1 and service B on node 2, and then IRTE does the communication underneath that. And you can find it, Jeff has mentioned it here, it's in github.com/containers/IRTE. HIRTE. It's apparently failing to build on the Copper right now, but that's something we'll look into. We are getting ready towards 1.0 release that we'll want to blog about, and it will contain the minimal set of information, the minimal set of features to start stop services on remote systems. Currently, it does what we want. It works the way we want. Which is nice. There are still more work we want to do to it, but it is it looks promising, and the performance-wise, it's doing a fairly good job so far. So happy to take any questions, but I don't want to necessarily to spend too much time on this at the moment. If there is the need or the wish to have a dedicated presentation, then maybe we can just have a proper slot where we go towards the architecture of it, how it works, how it communicates, how you can use it, what are the assumptions of use, and so on.
Sounds good. Thank you. Do you think it's fair to say that this software was developed essentially in the context of AutoSD? So
Yeah, it was definitely. It's definitely meant to be running in the automotive context and for the AutoSD down the line. It's not yet in AutoSD proper because we haven't made a proper 0.1 release. But the idea is to add. Once we do a proper 0.1 release, then we'll package it for Fedora, have it in Fedora, have it in Apple, and then from there bring it into AutoSD so that people can easily play with it.
I would say that there's nothing specific about AutoSD. I mean, if you basically had 2 or 3 nodes that you wanted to, coordinate with systemd events across 3 or 4 nodes, and this would also work for that. It's not, it's not really that. And I think CoreOS had, I'm mental blocking on the name, CoreOS had a project years ago that did something similar to this, where you were relaying systemd events between nodes. So I think it would be handy for people just managing a small cluster of nodes.
It was designed. Yeah, I agree with Dan there. It was created for Automotive, but it can be used outside of it. The one limitation that we have currently for really public use, I would say, is that we don't yet have anything that allows to do authorization or encryption. So we don't have any TLS communications here is not encrypted because for the use case we have in mind currently, the encryption is handled at a lower level. So we don't have to care about it. We don't have to deal with it at the RT level. But if we open this to a more public infrastructure where the encryption is not taken care at a lower level, then having some support for encryption here will become necessary. So there will be some work here to do. But in the fundamental, I agree with that. The fundamental is applicable to practically anything.
Okay, fantastic. Any questions on that from the group? All right. Definitely take a look at the article, the Containers in Cars article. It explains things quite well as well.
It may be worth also to bring forward another couple of blog posts that were written. One is from Dan, and that's introducing Quadlet, and the other one is from Eagle, and it's again about Quadlet, but then doing Quadlet with a little bit more meat example, a little bit more. It's a multi-container example, and so Quadlet is a mechanism that was recently added to Podman, which allows you to easily manage start container from systemd. So it basically, you create a .container file or .cube files, and that .container files contains very simple instructions on which container you want to run, how you want to, which container image do you want to run, which commands do you want to run in that container image, and so on. And then once this is done, when you do a systemctl reload or a systemctl daemon reload or reload daemon, and then or basically at boot time, this .container file is automatically converted into a .service file, which has all the long podman commands. So you don't have to care about exactly how podman is set up, which C groups configuration do you want to use, and so on. This is automatically handled by Quadlet for you. So all you have to take care is a small container file, which is fairly self-descriptive, and so there are a couple of blog posts here with a simple introduction to Quadlet, and then a more lengthy example with more complex of multiple containers and secrets and so on. So if you're using containers and systemd, those are probably things you should have a look at.
I can also post a link to the Automotive channel on the Red Hat blog, which is kind of the overall place where these things get published. And here you can see them.
Yeah, I'm not sure the Quadlet ones are under there, though. The Quadlet ones are under sysadmin, although we probably should link them up. This.
Okay.
redhat.com/sysadmin, you'll see the Quadlet ones.
Right.
The interesting thing about Quadlet with Herta is Quadlet's all about running containers underneath systemd unit files in a simplified manner. And then Herter is all about managing systemd unit files across, one or more nodes. So the integration of the two allows us to run containers under Herter is really what the goal is. But
I see. And I posted links to all these in the chat here. I'll make sure that gets posted after the meeting as well.
Some bedside reading.
Here's some bedside. Yes. Here's the Quadlet article. Very cool.
If you scroll down, you should see a real simple Quadlet in here. You see the.
If you zoom in here in the pink.
It's kind of yeah. Can you increase the font a little bit?
Maybe. How about that?
Yeah. So if you look underneath the container section, the only thing you required inside of a Quadlet is to have a container section that looks like that. Mentions basically. I mean, all you really need to mention it is the image name. In this case, we're overriding the image name with an exec, but and then you can wrap it with all the standard systemd type stuff. So if you wanted to throw this into a specific C groups, if you want to, launch this before or after certain applications are up and running, you can do all the standard systemd stuff. But underneath the covers, what the Quadlet, systemd, Quadlet, and Podman will do is generate a much more complex service file. If you scroll down, you'll see that the service file that it generates.
Again. There.
And so this builds all the smart, basically all the intelligence that we've developed over the last few years of figuring out how to best run Podman as a systemd service. So if you scroll down a little bit further, you'll see the exec stack command. And
just above. Yeah. The exec start here with Podman run.
Yeah. So you can see that the command is pretty complex for, and it's taking advantage of some systemd things like the %n is injecting the name of the unit file into the container, and then setting up some other features underneath it. But you get the basic idea that our goal here is to make it real simple for people to create unit files that are running containers. And then as we get smarter or better about building, new versions of Podman might come out with fixes or improvements to this so that you don't have to modify your unit file ever. We'll improve the unit files as we go forward and improve the capabilities.
Do we think that it'd be useful to dedicate one of our automotive SIG sessions to a demonstration of all of this? So I think it'd be really useful to see it in action.
Yeah, I think probably the combination of the two.
Okay.
I'm planning on doing a whole talk on. I've submitted it to DevComp Check and
excellent. Okay.
Other places to basically do a talk on containers and cars. I call it containers and cars, which will cover a lot of these features and functionality.
Yeah, we also have a talk about it, a talk specific to it, also scheduled for DevCon CZ.
Yeah, so a more in-depth one for Herter, but the general concept of things that we're thinking about for, as well as separation of ASIL-B from QMs.
Okay,
containers instead of that.
Great.
But yeah, if there was a specific place to give that type of talk, then I'd be willing to do it. Or wrangle Pierre to do it.
There's a container con. I don't know if that would be of interest. It's a container conference. Container conference in concert with KubeCon. I don't know if that would be useful or not.
Yeah, the problem is getting talks into those type of conferences are usually fairly difficult.
KubeCon is a very big tent event.
I've had a lot of scars from trying to get talks in KubeCon in the past, so a little shy on that.
Right.
Especially where people might think Herter is a competitor against KubeCon, even though it's not intended to be Kubernetes. So, so that would be potentially an issue.
Okay. Okay. Well, any questions from the group on these containers? Because we've got obviously a lot going on with containers. If not, in the interest of time, we will zip back over to our agenda if I can find it. So the other thing we wanted to cover here is the external compatible images. Um, as an open source project, the CentOS Automotive SIG is very conversant with both SOFI. The SOFI is an ARM initiative. It stands for Scalable. I should just look it up because I know I'm going to get that wrong. Scalable Open Architecture for Embedded Edge. This is an architecture built around a vision for software-defined vehicles as a software architecture. And the work going on in SOFI is we feel is very important to the automotive world as it kind of expands or evolves into this kind of a framework. And one of the things some of the things that you can see here are the fact that this is all container based, and that's why we've been putting so much work into things like Hirta and Quadlets. And so in service to the work here, SOFI has basically two major tracks. One is creating a set of reference software. It's source based. It's currently built with Yocto project, and the other is a specification. And the work on the bits, of course, is always moves faster because working on bits is more fun, and you can tell when things break, which you can't really do with the specification. But the specification work is coming along. It's due to be published, I believe, in the next week or so. And everything buzzing at once here. So what we have also provided here is a version of CentOS that employs that corresponds to the SOFI vision, the SOFI architecture vision, and you can get to that in the images. Just take a look at the nightly images, and one of those images. Am I in the right spot? I'm not in the right spot, am I? I'm not in the right spot. So anyway, if you scroll down with the sample images, you can see that there is a SOFI image here that is built nightly. That in which SOFI also, or in which AutoSD also has the same features as EWAL is the reference architecture underneath SOFI. So this is one of the ways that we work with the SOFI project in order to kind of further this image or this vision. We're starting to do the same thing now with Eclipse SDV. Eclipse SDV is obviously the software-defined vehicle working group underneath Eclipse. Eclipse SDV has, I believe, 14 projects now that are all focused on various aspects of software-defined vehicles. There isn't an overarching architectural vision yet with SDV in the same way that there is with SOFI, because the project is essentially brand new. I believe it's celebrating its first anniversary this month or next month. So so there is an effort underway to kind of gather all of these projects together into a landscape, not really a software architecture, but more of a landscape, so that people can see how they act and interact with each other. And we have an SDV image now as well. It's in its own repository, so that it can be consumed by some of these projects. And it currently supports the Eclipse eCal project, and I know that there's some work. Leo's doing some work right now to support some of the others. So it's all interesting stuff. They're both in their own repos. We're working closely with these organizations, and we'll continue to work closely with as many of these open source initiatives as we can around software-defined vehicles. So the only other thing that is ongoing that we don't have a presentation for yet is a process for incorporating new hardware. I know that that has been a question from some of you, or at least from some people. I don't know if anybody's on this call who's been asking that question, but we are working on it. It is not as easy as it sounds. You can't just kind of throw a board into a mix and hope that it kind of comes out. There's a porting process, and there's also a process that we need to follow. So we should have an answer for that probably by the next meeting. Gary, do you think that's fair to say?
Yeah.
Okay.
It's proving to be surprisingly hard to find the exact right person at Red Hat to talk to, and try to get them to talk with us to see what the process would look like. So
Right.
it's definitely a work in process. We've made progress. We've identified the workflow that we believe would be the suitable one. There are still boxes in these workflows that we are unsure about, and we're trying to find the right people to get the answer to these questions. And so, some people also time off from work, which also then delays getting answers. So it's definitely work in progress. It's not something we have dropped the ball on, and I hope we'll have we'll have answers soon, because we've been at it for I don't know, a couple of months by now, I think.
Philip?
Yeah, a question about hardware. What is your vision? Do you envision you Red Hat to support a certain amount of reference hardware, or you expect the community to provide some board support package and have a way to include this board support package in CentOS Automotive repo?
And that's a great question for Pierre, I think.
I can take it. I think the former. So my understanding, and I'll let anyone here who wants to contradict me step in, is that we don't want to. We are providing a Linux distribution, and therefore that has a coherent set of packages and features that are tested together, and one of these package is going to be the kernel. And my understanding is that we don't want to have a kernel per board. So we will want to have a kernel that is compatible with, all the boards that are of interest, and that would be it. So having a mechanism where people could expand the supports of the kernel for a specific board. I am not aware that you can easily do that out of tree without without recompiling the kernel. But if you recompile the kernel, then you're no longer using the AutoSD kernel. And if we're speaking about the product, then you're no longer using the in-vehicle OS kernel. That is the one that is part of the product and supported and certified and all of it. Does that answer your question, Philip?
It's a question of choice. Okay, it's obvious that for some of the hardware that we are currently using in project, it's never going to fly because we don't have enough resources. So we have to skim down the kernel, and in fact, we have to skim down the full Linux to support what we have to support. The first thing being to boot in less than 5 seconds. Okay, so that's clearly. Potentially a thread. The second thing is you're never going to support enough hardware to respond to the community need, okay? Because everyone is going to come with some kind of probably SoC, reference SoC, or there are not that many SoC, or NSS, NXP, TI, Qualcomm, so it's pretty easy to have all of them. But people will come with their own I/O, and one will have 3 cans, the other one will have 2, and say 1 gigabyte internet and so on. So it's tough to respond to everyone without providing people the capability to do customization on the hardware.
So they could do customizations in the Automotive SIG as long as we work together, so that the changes are not stepping on each other's toes, so that by enabling your board, you're not disabling my board.
I understand that. I don't say there is an easy answer, but it's clear that if we look for Yocto, and I'm not part of the Yocto fan club, even if we know it pretty well, it's one of their strengths. Okay, it's very easy to support a lot of custom hardware, and so it's something we have to address. Otherwise, people will not be in a position to use the system, even for development.
I agree.
I'd say that these are ongoing questions. I mean, what we're really doing is that Yocto is really based on an embedded design and build paradigm, and CentOS really isn't. So we're kind of maybe changing that paradigm a little bit in order to accommodate some of the features in the software-defined vehicle world that are maybe more challenging from a source-based.
It's even one way where what we work on is not a direct competition to Yocto.
Exactly.
Or to some extent HEL, because the markets that we're targeting are completely different.
Mm-hmm.
If you have a very small device that needs a very specific kernel with everything trimmed down to be able to fit into the flash and the memory available, that's, as far as I know, and so far, not the type of hardware that we've been looking for.
Right.
Yeah, but to be honest, in project we have currently with customers, they have small hardware with very specific features, and they nevertheless want to have a per package distribution with long-term support and making sure that the QA team does not break the kernel and the middleware team is not in a position to change kernel parameters and so on. So it's not black and white. There is a lot of gray zone, and people are clearly willing to leverage the high-level capabilities that we have in the cloud, like containers per package, repeat, very fast update on only one specific feature in case of vulnerability, and at the same time they're willing to have cheap hardware with a lot of functionality. So.
Mm-hmm.
Mm-hmm.
I think it's also important to realize that this is all evolving now. There's none of the entire SDV paradigm is not really something that exists in the world right now. So
I have another question on more like the collaboration with the external organization. I'm surprised that no one came out with the Covesa VSS framework, because we see this as a very important feature for our project. Okay, so for people who don't know that, VSS is a normalized way to represent signal that you extract from the car, okay? Which is obviously a hot subject because we have a lot of signals that we have to deal with. And QuickScar inside Eclipse is one of the projects that leverage VSS. So VSS is a collaboration in between Covesa. Covesa was used to be Genevieve in the past, the changed name, and 3GPP.
So I don't know if I heard a question there, but I can't say that we're absolutely working on that at the moment, but I think we could definitely put it on the radar to explore.
If we're the only one who are, who need the VSS, I understand that it's not included, but I'm just surprised because we see a demand for VSS, like we see a strong demand for container cybersecurity, and it's part of the hot subject.
Yeah, I think we should definitely explore it. I think that certainly Covesa has been around for a while and has established some very interesting standards. I think I would like to explore that some more. So I will take an action item to do some exploring on that. It's just we just haven't gotten to it yet. We're still sort of working on some of the more basic things. So, well, we are at time. So I wanted to say if there's any other questions, feel free to jump over to the mailing list. Hi, Jeswin.
Yeah, hi. Myself Jasmine. I'm working in UST, India. in embedded projects. So recently, I've been looking over through your CentOS automotive distro, and I have a major doubt. That is, I need a comparison between the CentOS normal, CentOS stream, and CentOS automotive distro. Could you please give me the comparison between them?
Do you want to show the diagrams that we have?
I can show the this one. Or you mean the other ones? Okay.
Probably the other ones. So basically, the first one there is, I think, good. CentOS Stream is the public in development version of the product RHEL, and Automotive Stream Distribution is the public in development version of the product Red Hat in-vehicle OS. And AutoSD is itself a derivative of CentOS Stream because we leverage the work that is happening in CentOS Stream, and the Red Hat in-vehicle OS in the same way is a little bit of a derivative of the RHEL product.
Yeah, okay. Do we have any functional differences between them?
The main difference that we have currently between CentOS Stream and AutoSD is the kernel, which is a real-time kernel, which is allowed to be built for AR64. And I believe the CentOS Stream also has the kernel RT, but I don't think they build it for AR64. And it has a few patches in Automotive SIG, not in AutoSD. We have a few patches. I think the Raspberry Pi support, for example, is better in the AutoSD kernel than it is in the CentOS Stream kernel.
Yeah, okay. Do we have support for IMX NXP board, NXP IMX board, IMX8?
I am not aware that we support many NXP boards at the moment, or at least the ones that are not supported upstream.
Okay.
Yeah, it's not currently being supported. I've seen a roadmap for sometime this year, but it won't be our team doing that. So I don't know the details. But I've seen being called as priority down the line. So we actually will inherit whatever work they're doing because they're doing it for
in CentOS Stream.
Right.
Yeah, okay, thank you.
Okay, great. What I was going to say is definitely if you have any further questions or you want to continue on the discussion, jump on over to the Matrix channel, which we have here, or the mailing list. There's a mailing list as well. And we meet once a month or so, and so we'll continue to do that. So I know everybody's at time and appreciate everybody's attention, and we'll have the recording up soon. Thank you all and have a good month.
Thank you.
See you in April.
Thank you.
Thank you.
Bye.